We have been asked to derive the SI unit of capital G. Now, capital G is universal gravitational constant. So we need to derive the unit, and that to SI unit of that capital G. So as per the formula, if you know children, it's F is equal to capital G mm upon, you can also take R square or D square, depends upon what you take. Now, this is the gravitational force between the two bodies. G is the gravitational constant. These are the two bodies of masses m and m, and the distance between their centers is taken to be r. So this is the basic formula by universal law of gravitation. So now, since we are deriving the unit for capital G, so I'll keep capital G to a side. I'll multiply this r square with f. So we have f into r square whole divided by capital M and small m. Fine. Let us do one thing. Now let us put the units everywhere. Okay. So therefore, capital G as it is, because we are deriving the unit for the same force. The SI unit of force, Newton. No doubt. So I'll write in words now literally. So Newton into this is the distance between the two bodies, correct? So obviously in SI we will measure it in meters. So I'll say meters, but square as well, because it's meter square, divide by, now this mass is being taken to be the mass of bigger body, and this mass to be the mass of smaller body, but both are mass. So in SI unit, we measure the mass in kilogram. So here also kilogram, there also kilogram. So now I'll just write kg and square of that. Okay, so now therefore, capital G, now for Newton I'll put N. For meter, I'll write meter square and divide by kilogram square. Correct, children? So now, finally, capital G would be Newton meter square. Now this upon, if I take it up, you know very well, this kilogram square, if I take it to the numerator place, this plus 2 becomes what? Minus 2. So I'll write Newton meter square per kilogram square. So I'm writing it as minus 2. Okay, this is the SI unit of capital G. Simple. Done.